Welcome back to Learn SQL Basics, Part 7. In this video, we're going to simplify one of the most powerful concepts in SQL, the case-when statement. Think of case-when like an if-else condition in programming. It allows you to add logic directly inside your SQL queries. This is extremely useful for creating custom columns, data transformation, conditional aggregations, and building smarter reports. By the end of this video, you'll be able to write dynamic SQL queries using case-when with confidence. So let's dive in and start mastering SQL logic. In this section, let's understand the SQL case-when statement. So what exactly is a case statement? The case statement in SQL is a conditional expression that allows you to add decision-making logic directly into your query. It works very similar to an if, elif, else statement in Python, where you can evaluate multiple conditions and return specific results based on those conditions. This makes your queries much more dynamic and powerful. Now, let's look at the general syntax. We start with the keyword case. Then we define conditions using when. If the first condition is true, SQL returns result 1. If not, it moves to the next when condition and returns result 2 if that condition is true. Finally, if none of the conditions match, the else block returns a default value, and we always close the statement with end. Using case-when, you can transform data, create categories, and build smarter logic right inside your SQL queries. In the next part, we'll see practical examples to make this even clearer. Now that we understand how the case-when statement works, let's look at some practical examples. In the first example, we're selecting first name, last name, and age from the employee table. Here, the case statement is used to categorize employees based on age. If the age is greater than 30, the result is labeled as old. If the age falls between 27 and 30, it's labeled as young. And for all other cases, it defaults to baby. We also ensure that age is not null. And finally, we sort the results by age. Now, let's move to the second example. In this case, we're working with job titles and salaries. Here, the case statement is used to calculate salary increments based on job roles. If the job title is salesman, the salary is increased by 10%. If the job title is accountant, the increase is 5%. For HR, a different calculation is applied. And for all other roles, a default 3% increase is given. The final calculated value is returned as salary after raise. We also join two tables, employee demographics and employee salary, to bring all the required data together. Now, let's explore how to use the case statement with the group by clause. In this example, we're creating a new derived field called ROI group, which helps us categorize data and perform meaningful aggregations. We calculate ROI using the formula gross divided by budget. Then, using the case statement, if the ROI is less than 1, we label it as low ROI. If the ROI is between 1 and 2, we label it as medium ROI. Otherwise, it's categorized as high ROI. This derived field is then used to group the data. Along with that, we calculate the average gross and the average budget for each ROI category. We also apply filters to ensure only valid data is considered, like budget and gross being greater than 0, and restricting results to the year 2015. Next, notice something important. The same case logic is repeated inside the group by clause. This is required because SQL needs the exact grouping expression to aggregate the data correctly. Finally, we sort the results by average gross in descending order, so the highest performing groups appear at the top. Another powerful benefit of the case statement is its ability to filter rows based on specific conditions. For example, imagine we want to apply different ROI thresholds depending on the language of a film. We already know that English films tend to generate consistently high ROI, so we can set a higher threshold for them. On the other hand, films in other languages may have comparatively lower ROI, so we apply different thresholds accordingly. Now, let's look at the query. We start with select title, gross, budget, language, and calculate ROI as gross divided by budget. then from cinema.films. Next comes the key part, using case inside the where clause. Here's how it works. When the language is English, we only include films where ROI is greater than 2, because English films are expected to perform better. When the language is French, we apply a slightly lower threshold, ROI greater than 1.5. And for all other languages, we use a default condition, ROI greater than 1.3.
Using case in multiple conditions is a powerful SQL technique for categorizing numerical ranges into meaningful groups. In this example, we classify product prices into 3 categories. If the price is less than 20, it's labeled as low cost. If the price falls between 20 and 50, it becomes medium cost. And if the price is above 50, it's categorized as high cost. This approach is extremely useful for pricing analysis, customer segmentation, inventory grouping, and business reporting.
Combining column criteria in SQL with case plus and/or logic to build smarter SQL transformations. We start by selecting the auth status and DOB fields from the member table. Next, the case statement applies different rules based on authorization and age. If the user is authorized, meaning auth equals Y, the date of birth is securely formatted into a standardized year MMDD format. If the user is not authorized, but their age is 89 years or younger, the original date of birth is returned as text in the table. If the user is not authorized and their age is above 89, the system masks the birth year by returning 1900 instead. For any unmatched scenarios, the value defaults to unknown. This approach is useful when handling privacy rules, age restrictions, or conditional data masking directly inside SQL queries. By combining and/or conditions inside case statements, you can create highly flexible business logic while keeping your queries clean and efficient.
One of the most advanced use cases in SQL is the nested case statement, which is essentially a case inside another case. This technique becomes very useful when you need to divide data into subgroups and apply different logic to each subgroup. Now, let's understand the scenario. Similar to our earlier example, we want to create a new column that is influenced by the values of ROI. As we discussed before, films in the English language generally have a higher ROI globally compared to films in other languages. So instead of applying a single rule, it makes more sense to use a layered approach. For this reason, we categorize films into ROI groups by considering both ROI and language. This is where a nested case statement becomes powerful, allowing us to apply multi-level conditional logic in a structured and efficient way. Now let's look at a practical example of a nested case statement in action. We begin with the query, select title, language, and calculate ROI as gross divided by budget. Next, we use a case statement to create a new column called ROI group. Here's where the nesting happens. When the language is English, we apply a nested case to categorize ROI. If gross divided by budget is less than 2, we label it as low ROI. If the ROI is between 2 and 3, we categorize it as medium ROI. Otherwise, it falls under high ROI. Else, meaning for all non-English films, we apply a different set of rules, using another case. If ROI is less than 1, it is labeled as low ROI. If ROI is between 1 and 2, it becomes medium ROI. Otherwise, it is categorized as high ROI. After applying all conditions, we end the case statement and assign it the alias ROI group. The data is then selected from cinema.films. Finally, we apply filters using the where clause. Budget must be greater than 0, gross must be greater than 0, and the release year should be 2006. This example clearly shows how nested case statements allow you to apply different logic based on multiple conditions, making your SQL queries more powerful and flexible.